both of these examples are examples where when we try to take the limit of sine of x over x or the cosine of x minus 1 over x, we end up with 0 over 0. And this is the original indeterminate form. This is the indeterminate form that we use to prove L'Hopital's rule. And so since it's that indeterminate form, we can use L'Hopital's rule to do this. So the first one, we have the limit as x approaches 0 of the sine of x. We always want to confirm first that we need to use L'Hopital's rule. Sometimes I'm going to ask you to do a limit, and you won't need to do L'Hopital's rule. It's just going to be a limit that you can evaluate in another way, whether it's direct substitution or otherwise. So to check that, what does the sine of x approach as x goes to 0?
0.
It goes to 0. So what I'm going to do is I'm going to kind of make some notes on here. So I know the numerator goes to 0. What does x do as x goes to 0? That one's an easy one. It goes to 0, right? So we get 0 over 0. L'Hopital's rule then says that we can evaluate this limit by evaluating the same limit, but by taking the derivative of the numerator and the denominator. So in the numerator, the derivative of sine is cosine of x, and the derivative of x is 1. So don't confuse this with taking the derivative of the whole thing. We're not using the quotient rule here. We're taking the derivative of the numerator, and we're taking the derivative of the denominator. And then once we do that, let's try direct substitution again. What is the cosine of 0? 1. So we get the cosine of 0 over 1, which is 1 over 1, which is 1. Does that make sense? So L'Hopital's rule is what allows us to go from here to here. It says that we take the limit as x approaches the same value, but we take the derivative of the numerator and we take the derivative of the denominator. So looking at that other example, we know the cosine of 0 is 1. So on top we get 1 minus 1, which is 0. On the bottom, as x approaches 0, the denominator approaches 0. So we get 0 over 0. That's the indeterminate form. L'Hopital's rule then says that we can take the limit as x approaches 0 of the top and the bottom. So what is the derivative of cosine of x? Negative sine of x? Is that what you said? Okay. What's the derivative of x? 1. And can we use direct substitution here? Can we put 0 in for x and evaluate it? Yes, we put 0 in. What is negative sine of 0? 0, so we get 0 over 1, which is 0. So those were two limits that we saw very early on in the year that we only were really able to evaluate by looking at a graph or looking at a table of values as x approached 0. Now we can use L'Hopital's rule to show analytically that it is equal to 0, and the first one is equal to 1.